Hey everybody, welcome back to EveryLastByte. So today what we're going to do is we're going to look at the kind of the compilation output of what's actually going on when we kind of run our program. And so, or when we build our program, what am I talking about? Yeah, so when we create our program, it's got to have that setup and that loop function, which I believe are in our bare minimum example. Yep, there they are. So this is kind of the bare bones of what we need. But what's actually happening under the surface? I mean, somebody told me that Arduino is actually C++. This looks like, well, it looks pretty much like what I knew when I started looking at Arduino. Two functions, setup and loop, that's all good. But if it's C++, then we're going to need some more than just setup and loop. We're going to need a main function, and maybe this is part of a class or something that I just can't see. So today we're going to look at that and see, kind of go one step beneath the surface and look at what's getting compiled, what's getting automatically generated, and kind of see if we can make any sense out of it. Okay, so I should mention that this is running on a Linux machine, but if you were to do this on a Windows machine or a Mac, this would probably be the same situation, just the directories where things are being created are probably going to be a little bit different. So let's get started. The first thing that I did was I went to my preferences and I checked these two boxes, compilation and upload. So now when I go to hit the compile button, it's going to tell me a lot more information than I thought I needed. And so let's do that actually right now. So we're going to hit the verify button, which is just to compile it. And there we go. This thing is, oh, it's huge. But there, we can start to see some temp/build, temp/build, temp/build. There we go. So now looks like it's a folder that's been auto-generated in my /temp directory. Why not pop that open and see what's going on there? So if I go over there to /temp, cool. There's a build that thing's talking about. So let's pop that open. And okay, this looks a little bit more like some C++. We've got okay, we see some CPPs. I'm looking at some CPPs. And okay, here's something that could be a main, but it's got this D at the end of it. That could be something else. But we compiled something that was called bare minimum, and that was bare minimum.eno. Let's take a look at this bare minimum.cpp. Maybe this is what's actually getting transformed over here. Let's see if I can bump the font up a little bit so it's more readable. Cool. Okay. So yeah, include arduino.h and line 1 bare minimum.eno. Okay, two functions, and then those functions again. So that's starting to look a little more similar. Maybe this is maybe this is actually a definition, and this is a declaration. So in C++, when you're writing a class, you'll have a header file and you'll have a CPP file, your source file, and those are generally kept separate, but you can put them together, and that looks like that's what they may have done here. Here's the declaration is basically saying I have a function, and it's called setup. But I'm not going to tell you what it does. If you want to know, you have to look at my definition. So we can go over here to void setup, and here's my definition. Of course, when I was actually opening up the example, I didn't write anything, so there's nothing here. So void setup, if I did type in some text and say this is what void setup does, it would appear here. The same thing with loop. Here's our declaration. Hey, I have a function called loop, and here's our definition. Hey, here's what loop does. Of course, again, I didn't write anything in there, so there's nothing. But cool. But still, okay, so it looks a little bit more like this could be kind of a class. It looks a little bit more like C++, but there's still no main, and that's kind of what we're looking for to kind of blow the lid on this. If I look at this main cpp.d, okay, not the main I was expecting, but here's a file path, and there's a main. So let's take a look at that. Why not copy and paste that and go there? Let's copy that, close that, and let's go there instead. Okay, I didn't type that in correctly. Looks like there might be a space. Yeah, there's a space. Okay, there we go. Okay, this looks like some C++. These look like they could be classes. Here's a CPP and a header file. So there's our source, and here's our header for a class that looks like it's like the stream class. Maybe we'll look at that later. But that's what we're looking for. There's our main. This could be the bare bones of what Arduino is running beneath the surface. And yeah, it actually looks like this is what it is. So here's main. The first thing it does is, okay, init. I don't know what that does, but maybe it's important. But then here we go down. Here's some conditional compilation. Maybe that'll happen depending on what board I chose when I started to compile this. And then here's setup. And then forever, we're going to run this function called loop over and over and over and over again. And it looks like we're doing a check here and some serial checking here. But now this starts to look like what Arduino is actually doing. I have a function set up, it runs once, and I have a function loop that runs forever, over and over again. Of course, I guess I didn't really know about this was happening also, but cool. So I've got loop and I've got this thing here. So this is pretty cool. I don't know if it's completely satisfying because we don't know what this init function is doing. It would be nice to know. But it's nice. We've got setup and we've got loop, and we know that the loop is actually running forever. This looks like C++. So just for kicks and giggles, let's take a look at init. Let's see if we can find it first. My guess is that it could be here. And so what I can do really quickly is kind of look for it at the terminal. So I'm going to go to that directory, share, Arduino, hardware, Arduino, cores, Arduino, that's humongous. Okay, so I'm here. What I'm going to do is I'm going to look for text in all of these files that have the word init. Maybe I'll get a function definition that way. So grep for init in these directories. Cool. Okay, so I got a lot of hits. And wiring.c looks like what could be the start of a function, because I don't see a little semicolon there. So let's go there, wiring.c. Which, okay, here we go. Wiring.c. Cool. There's a license. And okay, this looks like it's getting a little bit more register-y. And release micros. And there we go. There's init. So here's the function that I didn't know was running before blowing the lid under the Arduino sketch. Okay, so what the heck is this? SBI, this, that. So the long story short is that these look a lot like register writes and a lot of conditional compilation flags. So these are going to the preprocessor. These are preprocessor directives that are saying if this is the case, then add this junk into my code. Otherwise, put this junk into my code and then compile it. And the idea here is it looks like they're trying to be as generic as possible. So maybe I'm plugging in an Arduino Uno and compiling it for an Arduino Uno. Or maybe I'm compiling it for a Leonardo or a Mega or a Due. I think the code has to, or at least the Arduino IDE has to be ready to do pretty much the same thing on all my boards, or my program basically has to work the same way, regardless of what model of Arduino I'm choosing. Unfortunately, the models of Arduino, they all have different registers at the very core level, and the processor is different. But then again, what we want is the same behavior. And so it looks like this init function is setting up a lot of particular registers for particular boards to get that same predictable behavior out of all of our code. And so yeah, a lot of register writes. So if we were to go to the datasheet and start looking up what TCCR4B is, we'd find that it's some register. And so yeah, that's pretty much it for this one. If you kind of a sneak peek, if you keep looking at this, there's also how they implemented delay and how they implemented millies and micros, those functions that we've used, or you could have used before in the past. I certainly have. Now we can go take a look later at how they're actually written, and they're in this wiring.c file. Okay, cool. So I hope you enjoyed, and stay tuned until next time when we keep blowing the lid off of more interesting stuff on Arduino. All right, until then, bye.